Hi everyone, it is Caitlin. For those of you who are watching for the first time, I am one of the chemistry lecturers that teaches across all 4 years of the Forensic Investigation programme. Here I am with Kate, another lecturer who will be hosting a video in the next couple of weeks. The other 2 people in the image are actually current students who were helping organise and run a STEM event. In this series of videos, staff will be expanding on key types of evidence that you will likely come across during your time at GCU. This week is all about that blood that was located on the table. What can we tell from it? You might be thinking that we should probably find out if it is human or animal, and you would be correct. The challenge is that distinguishing between the two isn't all that easy. Visually, there is no way that you can tell them apart. One option would be to test the nuclear or mitochondrial DNA. It is a reliable approach but can be time-consuming, costly and destructive. This is not good if the size of evidence is small. Recently, researchers have been investigating additional chemical techniques. The most confirmatory techniques include Raman spectroscopy and attenuated total reflection Fourier transform infrared spectroscopy, quite a mouthful. Spectroscopy techniques use light to distinguish between different types of bonding within a molecule using light, which is great because blood is host to a range of many different molecules. This includes proteins, lipids, nucleic acids, and carbohydrates. Each molecule will absorb light at a different amount of energy. If you took physics in high school, you will be very aware of the light theory, perhaps a prism experiment. But if not, don't worry, because we will look into this in more detail from a chemistry perspective. The amount of light absorbed will coincide with the concentration of a specific molecule, and the concentrations of proteins, lipids, nucleic acids, and carbohydrates will be different depending on species. With some fancy statistics and genetic algorithms, you can very quickly tell the difference between human and animal blood without destroying that evidence. This is still a developing area in forensics, but pretty cool. Other techniques you might have thought about is blood splatter and DNA analysis. Also very important. I'll cover this in more detail later in the series, but for now, enjoy the rest of your day and keep investigating.